For these inverse trig problems, it's really important to recognize when the variable, especially since these are variable expressions, it's important to recognize when the variable is an angle versus a ratio. So in this case here, the a is being applied to the inverse tan, so that's the input for the inverse tan. Well, that must be a ratio. That must be the tan ratio. So when I draw this in, I'm going to draw it in this way. Okay, so my ratio is inverse tan, as A, and my triangle now looks like this. Now, there's a domain restriction on the inverse tan, in that the output of this is always going to be only in these two quadrants. Okay, so inverse tan is actually a function, so the output is only going to be in these two quadrants. So I'm going to just highlight that here. Okay, so the inverse tan, that expression represents that angle theta. So this represents now the angle theta. So I want to take the tan of that angle theta, the sine of that angle theta. Well, the sine of that angle theta is going to be the y over the radius. Okay, so there's my solution. For this one here, again, it's important to recognize, is this x, does this represent a angle or ratio? So this is a sine, so this input for the sine must be an angle. Okay, so here it says angle is negative x, where negative x is less than 0, so it's going to be in quadrant. We're going to draw this in quadrant 3 or 4. Okay, so this is going to be, we're going to draw it like this. So that's going to be my negative x angle in that way. Okay, so this is going to be my sine of negative x. Okay, so this is going to be the cosine of negative x, okay, as my x and y positioning. So then I need to take that ratio here. So this length here, okay, so I'm just going to maybe highlight that. So when I talk about this sine of negative x, really I'm talking about the length of that line there. And I need to do the inverse cosine to it. So that means that this line has to be an x position, which I'm going to find the angle for. And that x position then has to be negative. So it's going to be something like this. Now I can still work with that triangle, because now I have this length here, that negative sine x, or sine of negative x, this length here represents the same positioning now, but in the x position. Okay, because now I'm dealing with cosine. Okay, so I'm just going to highlight that fact that this is cosine means that I have to take that as an x positioning. And I need to then figure out what angle, where's my angle here, what angle represents that position. Okay, so that's going to be the angle that I'm looking for. That's the angle theta that I need to solve for. Well, the only information I'm starting with is angle x. So again, this is why it's so important to recognize when I'm dealing with angles and ratios. Okay, so my angle x is going to be, that's going to be my reference angle there. So the positional angle for angle theta is going to be 180 minus that angle x. So theta works out to be 180 minus angle x. Okay, and then I'm using my reference angle as that angle x in here. Oh, I think I just made a mistake here. I need to requalify that. I just realized that angle x is actually going to be up here. So it's going to be this, if this is my long length, that's my long length. The x has to be in that position there. So this is going to be 90 minus x. Okay, so then the angle theta that I'm looking for is 180 minus that reference angle of 90 minus x. Okay, so this works out to be 180 minus 90 plus x. So it's going to be 90 plus angle x. Okay, so that would be the same as saying that angle in there is this angle in here is angle x, which it is because of parallel line properties. So there it is. So the answer for this is the inverse cosine of this ratio is going to be 90 plus 90 degrees plus x, or this position right there. Okay? So this one here is a particularly difficult one. The ratio, when we start with the ratio, is a little bit easier than when we start with the angle, because when we start with the angle and get a ratio, and then if we change the function from vertical to horizontal, we still need to change this vertical positioning to a horizontal positioning to do that. And the last part of this is that ambiguous case. These are the special cases. Okay, the regular case here is going to be our 2 triangle 1. Okay, and you can study this chart here. This summarizes the special cases and the regular case of the angle side.